Hi, so I'll just get you started on this. I haven't used this specific module, so I just needed a second to figure it out. So you open up, go to Model Wizard. Looks like a two-dimensional problem. And then I would go to Solid Mechanics. I have a feeling there's more to this problem, so we might all need to meet um, me and your professor. I don't see any time dependency yet, and the time dependency looks like it's based off flow. So yeah, if there's flow, I need to know where it's going. Like I need a better CAD drawing. So right now I'll just get you started on the statics of like applying a stationary force. Um, Actually, no, I can do time dependent because why not? So we'll just call this your cross section. Looks like we're working on like the centimeter scale, which will just set the size of our window. And then I'll go to geometry and sketch out your rectangles just approximately. And then in parameters, I can put in specific things so we can change them easily in the future. So square brackets on SI units. And you should give them descriptions. What else do we have? G 2.5 gigapascals. Density 1.24 grams per centimeter cubed. Poisson's ratio. So yeah, like I said, I'll need more information on why we need heat. Like heat information. But I think this is all we need right now. So I assume that the red parts also get compressed. I'm going to treat them as a uniform material, and I'm just going to use rubber. So I'll show you how to change the properties as we go, but anyway, we can go back to this rectangle we drew. Seems like the width doesn't matter, so we'll just use just based off your drawing, it looks like maybe it's 5 times as long as it is thick, so I'll do dx times 5. And the height will be dx, and then just hit build all objects. So that got really big. Okay, there's your first shape. It looks like and I'll rename it top thing. I don't really know what it is. I'll duplicate it. So same exact thing, but we'll shift it down by delta H. So minus DH, build all objects. That didn't work. Why did that not work? Sorry, I just got an email checking that. Okay. Well, my arithmetic sucks. We'll just do it. Draw it again. So width will be dx times 5 again. Height will be dx. We'll call this the bottom thing. And in between, So the height is 7.8. So we'll call it DH instead. And I'm just gonna redraw it so I don't have to do the math. So yeah, once again, the height is dx. So it looks like your drawing isn't to scale, which is fine. Just keep that in mind. So they're all linear elastic materials. So like I said, I'm going to call the top and bottom rubber because I don't really know what they are. So I just clicked on materials, came over here, rubber. The middle isn't rubber, so I'll deselect it. You can see what's selected here. And then I come down here, make sure there's not any red stop signs, which will tell me it needs more information. Then I'll have a blank material for you. Then you click on what you're interested in, and it'll tell you what it needs. So G, PR, these are just from the parameter window. Use parameters because say you wanted to see what the effect of changing the density was, you could just come right here or do a parametric study. Okay, I'm curious if that will work. I guess it didn't apply a force. So far we've drawn our shape, we've applied our materials, but we need to apply physics to it. So everything is linear elastic based on your problem. Gonna have to have another meeting about your strain stuff. So I don't see where there's strain. I guess one of these red things could be moving, but so what we'll do is we'll do a boundary load of whatever static pressure you want. So just for argument's sake, I'll do 1,000 pascals. See what happens. You can click here, make sure things are trending downwards. Okay, so it did it for 1 second. That's the displacement you would expect. You can come into the study section. So if you wanted to go longer, you click here. So say you wanted to go days, you could do that. So like 1 hour. Compute it. Oh, well, I put that in wrong. Ugh. Step 0.1. Checking at convergence is going down, which is a good sign. Just means that with every step we're getting less variance. So as you get closer and closer to the solution, your updated solution goes down. So I think this will work out. I'm not going to wait for that whole thing. But yeah, generally that's how it works. If you want to see how it would be in the end, we can add a study, some add study. So we could do stationary too. To just see what it would be like at the end of time. Failed to find greater than the relative tolerance. So we just have to mess around with the tolerance and the mesh size to get that to work right. But that's the general concept. I hope that helped. I'm willing to help more, but I need to get some sort of like acknowledgement or at least know what I'm doing. So I'll let the two of you guys figure that out. All right, see ya.